yellow sheet of paper, we're going to do two different activities, so you can go ahead and turn it on now. So we're going to do two different things, and you are going to be high school. So magically transformed. You are high school students. You are not college students. So I'm expecting you to act like college students. But you are going to have the knowledge base of a high school student. Now, as a high school student, you're also awesome, and so you listen and you follow directions. Okay? So today's lesson is we're going to work with the angles that are formed when lines are cut by a transversal. Yesterday in class, in your high school class, we went over the names of the angles that are formed. Okay, so for today, we're going to look at some properties. So what I want you to do on your yellow sheet of paper, you can hold it either vertically or horizontally, it doesn't matter. I want you to draw two non-parallel lines and a transversal. Okay, so you're going to draw, you can use your ruler. Using your ruler, you're going to draw two lines that are not parallel and a transversal. Okay, you're going to make it large. You're going to use the whole sheet of paper. Okay, you draw it with enthusiasm. Make them big because you are going to be measuring the angles. So you're drawing two non-parallel lines. And you're going to cut them with a transversal. We're going to label the lines. Our transversal we're labeling T. This line is L and this line is M. When we're labeling our lines, they're in lowercase cursive. When we label a line using one letter. Okay, how many angles do we have? 8. Okay, so we're going to label them. Now, when we're going to be referring to the angles, we all have to label them the same way. Okay, so angle 1, 2, 3, 4, 5, 6, 7, and 8. Okay, there's nothing special about the way that I labeled them, but I want you to label them the same way I did so we can talk about it.
Does the transversal have to be in the same direction?
No. Okay, that's a good question. Okay, your transversal can, I mean, I'm just an optimist, so I always draw with positive slope, but that's okay. Okay, it doesn't matter, as long as it's, your lines are not parallel. Okay, now what I want you to do is we're going to turn the document camera on, but it's not cooperating. So what we're going to do is you're going to measure each of the angles. Now, just as a quick review, okay, when we're going to measure the angles, if your angle is like this, what would you expect your angle measure to be? Very good. Okay, this is, what's the name for this angle? Okay. So when it's an acute angle, your measure should be less than 90. And when it's like this, Okay, so it's gonna be more than 90, but less than 180. I'm telling you that so that you can make a quick check before you measure your angles, because one of your angles should be acute and one of your angles should be obtuse. Okay? It's gonna matter. Yeah, just look. It's just, there's so much fun stuff with it. Okay, so go ahead and measure your angles. Remember, how do we use the, there it is. Just as a quick review, when we go to measure an angle, we're going to put the center of your protractor right on the vertex of the angle. So this angle and the line should line up. If your angle's not, your line isn't long enough, then just extend it. And then we come over here. So this angle that I have, that's from here to here. What would you expect my angle measure to be? This one right here. Is it more than 90 or less than 90?
Less.
Less than 90. So when I'm looking at it, I'm going to have, line it up, and so I can see that it's going to be the 50, 1, 2, 3. So I know my angle's 53. Okay, just as a little quick check. Okay? So go ahead and measure all 8 of your angles. Did you rate mine? Okay, we're going to measure to the nearest degree. You don't need to put in half degrees. Okay, so we're just going to take and label each one. You don't need to put the little part. I did because I didn't know where mine. Okay, as you do that, once you finish measuring, I want you to see what patterns you notice.
Oh, no, they're not.
Measure them. Just guess. Okay, I'm expecting you to measure the 8 angles. Okay, so I like this activity because it causes the students to go back and review measuring their angles. Run 9 parallel. Okay, don't erase this unit. We're looking for their non-parallel lines, and what do we notice? I'm asking you, what patterns do you notice? So what do we see?
The vertical angles, the angles are same.
What do you mean opposite angles? Okay, for instance, which one's here?
At 2 and 4.
2 and 4. Okay? Did everyone get that angle 2 is congruent to angle 4? What is the name for these 2 angles? Vertical angles. Okay? So we have that vertical angles. Are congruent. So we have, you said it's angle 2 and angle 4. Which other are the vertical angles?
1 and 3.
1 and angle 3.
5
5 and 7.
7 and angle.
6
Okay. So our vertical angles are congruent. I could have written them this way, or let me just put the congruent sign. Just. Okay. Angle 2 is congruent to angle 4. Angle 1 and 3. Okay. So our vertical angles are congruent. Okay. Very good. What else do we notice?
The equal one.
Which ones equal 180? Which ones?
1 and 2.
Okay, so angle 1 and angle 2, so they add up to 180. What else can we say besides that they add to 180? They're supplementary. What else are they?
Adjacent.
They are adjacent, and because they're adjacent and add up to 180, what is that term?
Street angle.
Okay, or we call it a linear pair. Okay, so all of that is true. So we could say that angle 1 and angle 2 are supplementary or linear pair of something like that. Okay, angle 1 and angle 2 are supplementary. What else are supplementary? 2, 3, and angle 3 and angle 4 and,
Angle 4 and angle 1.
okay, angle 4 and angle 1, and
5 and 6.
the other set right here. Okay, so we've got a lot. 5 and 6, 6 and 7, 7. Okay, so now you see why I wanted everybody to label them the same way. So you should see this on your paper. Okay, which is great. But those are all review things that we already have covered earlier in the semester. Okay, what we're going to do differently today is I want you to now draw on the other paper. I want you to draw 2 parallel lines and a non-perpendicular transversal. Now, how are you going to draw 2 lines that you know are parallel on unlined paper? Okay, we're not perpendicular. How are we going to draw 2 parallel lines on your paper where you know that the 2 lines are parallel? So it's easy if I give you line paper. Just use the lines. Okay? They're not, there's no lines on your paper. How are you going to draw 2 lines that you know are parallel? How? Using the ruler.
You measure the bottom on one side, whatever you choose.
Okay, you could do that. How else can you do it using the ruler?
Just draw one side and then
That's probably going to be the easiest way, okay? Is to just draw. This is one line, and this is the other line. Okay, because you're going to use paper, so you might as well. Okay, so put that somewhere in like the middle of your paper. Draw from the top the line and the bottom the line, and then a non-perpendicular transversal. Okay, and then when you do that, or after you do that, what I want you to do is label it the same way we labeled this one.
Oh, can I call it close?
Okay, and then after you do that, what I would like you to do is to measure all 8 of the angles. So So I labeled them the same way I had here. I labeled my angles the same. But now I want you to measure the angles, all 8. I'll label it the same way. The same way. Got it? Here, the line here, over here. And then on this side, start. Yeah, no, I got it. There you go. And now draw transversal, you just need one, so it's easy. Parallel lines. Just color, just. And after you measure all of the 8 angles, keep in mind, you're high school, so you don't already know the answer, so you need to measure them. Okay? No cheating, you can't use your college brain, you're gonna use your high school brain. Okay, measure the 8 angles, please. So after you have measured the angles, what I want you to do is to look for patterns. No, as you mentioned. High school, yes, it's college brain that just gets in the way. The other one. Okay. So, my first question is, what we noticed here when the lines were not parallel, are these observations still true? Are these vertical angles still congruent? All of these, okay? Are all these 8, are these all true? Okay? Are there more things, more patterns that you notice? Okay. So, I'm gonna look at those, okay? What's one pattern that you noticed?
The angles 2 and 4, and 6 and 8 were all congruent to each other.
2 and 4, 6 and 8. Okay, so these are vertical angles. So without using the ones that we already know, without using the vertical angles, and without using the ones that are supplementary, just give me a new pattern. So if we don't say 1 and 2 and 6 and 4, just give me 2 angles.
4 and 6.
4 and 6. Okay? So did everyone get that angle 4 is congruent to angle 6. And is that only true when the lines are parallel? Was it true over here? Okay. So we can write that when what kind of angles are those? 2 and 4. It's an alternate interior, okay? Which is wonderful, because that's what we studied yesterday. All the vocabulary terms yesterday. Some of you weren't here. So finally, like, how did we know these terms? Here we did them yesterday. You're absent. Okay? Angle 4 and angle 6 are alternate interior angles. Why are they alternate? See why they're alternate? They're on opposite sides of my transversal, and if you think of this as like a box, they're on the inside. Okay? So not only are angle 2 and 4 alternate interior, where's another pair of alternate interior angles? Right here, 3. Okay, so we have angle 4 and angle 6, angle 3 is congruent to angle 5, so we can say that alternate interior angles are congruent. Did it work when the lines were not parallel? So if we had lines, and well, we just did 2, but we could have more lines. But if you have lines that are drawn and they're cut by a transversal, and if your alternate interior angles are congruent, what does it tell you about the 2 lines? They're parallel. Okay, so we have a statement, which at this point is a conjecture, we haven't proven it, but we have a statement and we also have the converse is true. So you just hypothesize 2 statements. Okay? Let's see, what else do we notice? Besides our alternate interior, 2 of these. 2 and 8. Did everyone get 2 congruent to angle 8? Okay, so is it only true when the lines are parallel? Okay, so when parallel lines are cut by transversal, the 2 and 8 are which ones? Alternate exterior. So we have that alternate. Okay, so we have this second statement. When parallel lines are cut by transversal, we have this as 1, alternate interior angles are congruent. 2, alternate exterior angles are congruent. Because you saw that angle 2 is congruent to angle 8, and which other ones? 1 and 7. What else do we notice? What other pairs of angles are congruent? So we have vertical angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent. 1 and 5. Okay. 1 is congruent to 5. What kind of an angle is 1 and 5? 1 and 5. Corresponding. Okay? So that means they're in the same position. They're above the line and to the left of the transversal. They're above the parallel line and to the left of the transversal. They're in the same corresponding position. So we get that corresponding angles are okay, so just to review the corresponding angles, we have 1 and 5. What other sets are corresponding? 2 and 6. Two. It's going to angle 6. What else?
40.
40. And 3 and 7. Okay, so there we go. So right now, at this point, we just made an observation. So it's a conjecture. So it's not actually a proof. We haven't proven it yet, but we're thinking, we noticed that. That's the inductive reasoning, when we notice a pattern. Okay, but not only did we notice these 3, but we also realize the converse is true. That if the corresponding angles are congruent, then, I mean, if lines are cut by transversal, corresponding angles are congruent, then the lines have to be parallel. So we have, what you demonstrated is 3 conjectures. We haven't proven the theorems. 3 theorems and the converse is a total of 6 theorems. You just came up with. Okay? So, what did I tell you? Well, I did. You all noticed the pattern. That's the inductive reasoning, where you are going to measure or draw, and then we can go ahead and prove them. But we're not going to prove them today. We're going to prove them another day, from a separate day. Okay? But we have, and what we also did, besides coming up with these conjectures, you also noticed that the lines have to be parallel. Okay? Because if you don't see that it makes a difference between non-parallel and parallel, when students go to write the statements for a theorem, for a proof, then they say, well, do we have to write them? Parallel lines are cut by transversal. They don't realize they have to if they don't see it makes a difference. Okay, so that's why we did this first, and then we did this here, so we see that it makes a difference. So to write the converse, when we switched it, we can say, if lines are cut by transversal and the corresponding angles are congruent, then the lines must be parallel. Okay, but we emphasize the difference with the parallel lines by your 2 different drawings. And you came up with the conjectures, and then we can go ahead, and what actually happens is one of these you have to accept as true, and then the others you can prove, but you can't prove these without having some basic assumptions. Okay, so that's what we mean by inductive reasoning on the math, is how do you get the students, basically, how do you get them to figure it out on their own? And that's by, and the geometry is wonderful, because they can just draw it and measure it, and they can figure out a whole bunch of stuff. Okay? And what's interesting, I think is interesting, is that the state of Texas, somewhere I have it written, they require, by law, for it to be taught this way. It says, I'm going to turn this back on. Let's see how long it takes. Okay, well, since the technology is not working, then I'll just read it to you. It says on the geometry 5A, it says investigate patterns to make conjectures about geometric relationships, including angles formed by parallel lines cut by transversal. That's one, and then there's several others. So it's required for the students to make the conjectures. Because they want them to see it, because what they figure out on their own, they remember. What we tell them, they forget. Okay, so that's why, and there's several others that they want them to also figure out on their own, such as the interior and exterior angles of polygons and special segments of triangles. But there's just a lot that they can figure out on their own. That's why they want them, there it is, get back. That's why they want them to figure it out on their own. And then after they make the conjectures, then you can go ahead and have them prove things. What I would do when I taught, because I didn't want to teach geometry for years, I would trade off. So I wouldn't have to teach geometry. But then there was one year that the principal said, you're going to teach geometry. And so I cried. I went home, I cried. I mean, literally, I cried. And my husband said, what's the matter? And I said, I have to teach geometry. So what's wrong with that? And I said, you don't understand. Geometry was the worst class I ever had. It was worse than in high school. I said it was worse than abstract algebra. It was worse than any of my college math classes. It was the absolute worst class ever. And he said, well, why? And I said, well, because the instructor had us try to prove theorems that we didn't understand. So they don't teach it like that. Well, what am I supposed to do? He goes, well, you're the math major, you figure it out. And so, but it just stuck with me what I had said, is we had to prove theorems that I didn't understand. And I said, so how else can you do it if you're not going to do it the way you were taught? I said, well, if the problem was we had to prove things that I didn't understand, maybe I can get them to figure it out for themselves. And so when I started thinking like that, how can I get them to figure out the theorems on their own, then that's why I taught it this way. So I carried my geometry book everywhere. I said, how do I get them, for every theorem, how do I get them to figure it out? How do I get them to draw it, to measure it, to figure it out? Even something simple like that vertical angles are congruent. They can draw, they don't have to draw the whole thing, but they can draw two intersecting lines and measure it and say, wow, these are congruent. Okay, that's it. And to propose that. And then when we see that these are congruent, but that these are supplementary. So if these are supplementary and these are supplementary, and these are, all of these are supplementary, then the only way that it works is if those are the same. Those are congruent. So they could notice it, they could tell me, and then when I would ask them, well, okay, so does it work all the time? Or is it just a Thursday thing? They say, no, it works all the time. Why? And so they would walk me through a proof, trying to convince me that it happened all the time. And that's powerful, and you can get high school students to prove something because it defends their position. I didn't have to, I mean, I would write it on the board as they're telling me, but they're walking me through a proof. And that's what they understood. Okay, we're proving it because we're trying to convince you. That's what a proof is. But we didn't have it all real formal, but they tried to convince me it happened all the time, but based on initially their observations. And so they felt they discovered it. They figured it out. And so that was powerful for them, and it was exciting because I didn't tell them anything. They figured it out, and I just kind of, helped push them in the right direction. But they figured it out. So then I started seeing the geometry differently. For most of the geometry, the students can figure it out. And then I realized if I could do that for geometry, I could do that for algebra. For working with the integers, the rules for addition, subtraction, multiplication, division, using manipulatives, they could figure out the rules. So I didn't tell them. They figured them out. And so much of the algebra and the geometry, like I said, and a lot of even the pre-calculus, they can figure it out by noticing patterns. Because that's what math is. It's patterns. That's what your formulas are just shortcuts for patterns. But if we give them the formulas, then they forget them because it's like, who cares? That's why, unfortunately, a lot of students think that math is just it's a bunch of rules we just need to memorize. And they go, this is Monday's rule, Tuesday rule, Wednesday rule, Thursday rule, Friday we forgot. We got them all mixed up when they would test on Friday. Because they don't know what rule to use when, because we tell them. But when they figure it out, then they own it, and they can go back and they can refigure it out. So here, they may forget the names of the angles, but that's okay when they're taking a standardized test, but they know which ones are going to be congruent because they figured it out. It's not okay, but we can deal with that. But they notice the relationships for so much of the geometry, and that's why we want you to teach inductively, or having the students think of it as, how do we get the students to figure it out on their own? So I'll work with you, I'm gonna work with you now on some of your lessons you'll be able to. I had a student, it was just this week, said, I can't do it. I couldn't do it for my lesson, because it was an apprentice teaching. She goes, I couldn't do it for the lesson today. I said, no, you couldn't, because it didn't fit. Okay, so you can't do it, I have to give you that disclaimer, you can't have them figure out every lesson. But there are a lot of the concepts that they can figure it out if you guide them, but not everything. So that's what we want you to think of, is how can you get them to figure it out on their own? Okay, so we'll work with you, I'll work with you here, I'll work with you sometimes in PBI, it's totally different, and in apprentice teaching, and even afterwards, I've done workshops for the alumni on how do they get students to figure out different concepts on their own. But that's what we're talking about with inductive reasoning. How can they figure it out for themselves? Came up with these three and the converse 6 theorems in one day. That's pretty powerful. Okay, and what I noticed when I would do this with my students, when they would figure it out, no matter what I asked them to do for homework, they would do it. Because they all were successful. They were all successful, and that kept them involved in the class. And they would go home, and you know what they would tell their parents? When they would ask, what did you do in school today? Normally, students say, oh, nothing. They don't mean they did nothing, because, teachers teach. They mean nothing. It's not nothing, period. It's nothing interesting. But when they would figure this out, they would go, Mom, I figured it out. Let me show you. And they would show their parents what they figured out in class. The parents would come in and think, what have you done to my child? All they do is talk about your class. All they do is talk about math when they come home. What have you done? Math? But they're excited because they're confident and they're successful. That's what's powerful about this. And so they're engaged, they're excited, they're successful. So at the end of the year, my students would say, Miss, I don't know why they paid you this year. Why? Because you never told us anything. Because we did all the work. But that's exactly this, well, see, they were too kidding. But I had them figure everything out. So they thought they had figured out geometry. They discovered it. Well, it's kind of like Christopher Columbus discovering America. I mean, you can't discover it if there's already people there. Okay, just like math. I mean, they had their math book. So somebody already knew this stuff. But they felt that they had discovered it. So that's what I mean when you think about that, is they felt that they figured it out. They discovered it, but people already knew it, but it was new to them. Instead of just being, a lecture. Okay? So you can go ahead and turn off the. Okay, so we do actually have a few more minutes.